and welcome to this lesson on Generative Adversarial Networks, GANs. Have you ever seen AI-generated images that look incredibly realistic, like a person who doesn't exist, or a painting that resembles the style of a famous artist? Or perhaps you've used AI tools that enhance blurry photos, create deepfake videos, or generate artwork from text descriptions? These mind-blowing capabilities are made possible by Generative Adversarial Networks, or GANs. GANs are one of the most exciting breakthroughs in artificial intelligence, allowing computers to create entirely new content, whether it's images, music, text, or even realistic video clips. But how do GANs actually work? What makes them so powerful? And why are they called adversarial networks? By the end of this lesson, you will learn what GANs are and how they were invented. The two main components of GANs, the generator and the discriminator. How these two networks compete with each other to improve over time. The training process and the role of loss functions in GANs. Real-world applications of GANs and their impact on AI-powered creativity. So, let's dive in. What are generative adversarial networks? GANs are a type of machine learning model designed to generate new realistic data that mimics real-world data. They were first introduced by Ian Goodfellow and his team in 2014, and since then, they've transformed how AI creates images, videos, music, and even deepfake content. Unlike traditional AI models that classify or analyze data, GANs are used for generating completely new data, whether that's a realistic human face, a new type of music, or even a photorealistic scene that never existed before. At the heart of every GAN, there are two main components of GANs, the generator and the discriminator, which work together in an adversarial relationship. The generator plays the role of the creator, producing synthetic data that appears as realistic as possible. It begins with random noise, similar to static on a TV screen, and gradually refines it into meaningful output, whether it's an image, a sound, or a video clip. The primary objective of the generator is to deceive the discriminator into believing that the generated data is real. Imagine it as an AI artist attempting to paint a lifelike human face from scratch. The discriminator, on the other hand, serves as the judge, acting like a critic or detective that analyzes data to determine whether it is real or artificially generated. Trained on real-world data, it develops an understanding of what authentic images, sounds, or text should look like. When the generator creates synthetic data, the discriminator evaluates it by comparing it to real data, aiming to distinguish between genuine and AI-generated content. Imagine it as an art critic carefully examining a painting to determine whether it is an original or a forgery. GANs operate as a game between the generator and the discriminator, a constant battle of improvement. Here's how the process works. The generator creates fake data, for example, a synthetic image of a human face. The discriminator evaluates the data, comparing it to real images. If the discriminator correctly identifies the fake data, it provides feedback to the generator, telling it what mistakes it made. The generator learns from this feedback and improves, making its next output even more realistic. The process repeats over and over, with both networks getting better and better. Over time, the generator produces incredibly realistic outputs that even the discriminator struggles to distinguish from real data. Continuously refine themselves until they can generate highly realistic and convincing data. Now that we've covered how GANs works, let's get an overview of the training process. Before training a GAN, we need lots of data for the discriminator to learn from. The better the dataset, the better the GAN will perform. The discriminator is trained using real and fake data. It learns to tell the difference between genuine and AI-generated data. Think of this like training a security guard to detect counterfeit money. The more real and fake bills they see, the better they become at spotting counterfeits. The generator starts producing fake data. The goal is to fool the discriminator into thinking the fake data is real. At first, the generator's output is terrible, like a child trying to draw a realistic portrait for the first time. But over time, through constant feedback, the generator improves. Once both networks start improving, we train them simultaneously. This means, the generator keeps getting better at creating realistic fakes. The discriminator keeps getting better at detecting fakes. This back and forth competition continues until the generator produces images that are so realistic that the discriminator can no longer tell the difference. That's when we know our GAN is well trained. GANs have revolutionized AI and are now used in many real-world applications, including 1. AI art and creativity. GANs generate photorealistic paintings, digital artwork, and AI-assisted creative designs. 2. Deepfake videos. AI can swap faces in videos, creating realistic but entirely fake footage. 3. AI-powered image editing. Tools like AI upscalers enhance blurry images into high-resolution photos. 4. Virtual fashion and design. AI can create new clothing designs, furniture models, and 3D objects. 5. Medical research. GANs help generate realistic medical images to train doctors and AI models. GANs bridge the gap between artificial intelligence and human creativity, making AI an incredible tool for artists, designers, and researchers. To recap, in this tutorial, we learned that GANs are made up of two competing neural networks, the generator, which creates fake data, and the discriminator, which evaluates the data. These two networks continuously learn from each other, improving their ability to generate realistic outputs. GANs are trained through an adversarial process, where both networks refine their performance over time. GANs are widely used in AI-generated art, deepfakes, medical research, and creative industries. GANs represent a major leap forward in AI, pushing the boundaries of what machines can create. Before you go, take your learning to the next level. Click the link in the description to access this lesson inside the MotivaLogic Academy Learning Management System. There, you'll find a quiz for every lesson, hands-on labs, and real-world projects designed to test and strengthen your understanding. While you're there, explore our full catalog of advanced, hands-on courses and downloadable resources, all created to help you move from theory to real-world expertise faster. Ready to gain real industry experience? Work on practical projects, collaborate with other professionals, and build a strong GitHub portfolio that sets you apart and accelerates your career. Click the work experience link in the description below to register your interest. Don't forget to like, subscribe, and share. And turn on notifications so you never miss a future lesson. Thank you for watching.